our kids. Okay, so today we're going to talk about the law of cosines. The law of sines helps us solve for sides and angles in oblique triangles, but we can only use it in 3 cases. Okay. Here we have the law of cosines, where we can use these formulas when we know side, 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 or side, angle, side. Yeah, I'm not giving you these, so that's a good point. Law of sines, I think we all know, right? Once you write these down, I'll help you figure out how to remember this, but yeah, I'm not giving you formulas, okay? Good talk. I want you to look for a pattern as you're writing down those 3 red formulas. What does the first part of the formula look like? Look for patterns as you're writing them down. If you know one, you know them all. Okay. And I'll kind of talk through how I want you to remember it. Okay. Okay. So Grayson made an observation that on the left side of the equal sign, you have one side and it's squared. On the right side of the equal sign, the angle matches that side. So notice how, like here we have a squared equals blah, 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 cosine of a. So the one angle that's in this formula matches the loner side over here, okay? Whatever side you have squared here, the other 2 sides squared are here, minus 2 times those 2 sides times the cosine of the angle that matches the loner side, okay? So whatever 2 sides you have here are going to match these right here, and then this angle matches this side right here. So if you only wrote down this first one, you can get these other 2 just based off of that pattern. Okay. So if we know side, 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 we can plug all 3 sides in here and solve for this angle. If we know side, angle, side, then we can plug in our 2 sides and that angle. It's always going to be across from our missing side and solve for that side. Okay. Now, there is one, yes. Yeah. Now, there is one 3-letter combination that we haven't talked about yet. Which one is missing from our 2 days of notes? Angle, angle, angle. What'd you say? Okay. If I asked you to solve a triangle and I gave you 3 angles, what would you tell me? The sides could be anything. Okay. Here's an equilateral triangle. Here is an equilateral triangle. Their angles are 60, 60, 60, 60, 60, 60, but they're 2 different sizes. There are an infinite number of solutions for triangles when you know just the 3 angles. You can make them big, you can make them small. So that's why we don't solve them, because yeah. All right, so we're gonna solve two triangles here. Let's talk about the first one. We know angle A is 55 degrees. We know side B is 3, and we know side C is 10. If you don't already have your calculators out, once you're done drawing this, please get your calculators out. We need to practice this process. I first want you to recognize that we have two sides and an angle in between. Since the angle is in between, we need to use the law of cosine. Okay, now our law of cosines formula has three sides and an angle in it. So the only thing that we can solve for right now is which piece? Side A. Let's find side A. Okay. Well, we know that the law of cosines is a squared equals b squared plus c squared minus 2 times b times c times the cosine of A. Please do not work ahead of me. I really want to help you with your calculator. You have a very nice calculator. Don't use it like a $20 calculator. Let's use it like it's the $100 calculator that it is. Okay, so this is what I want you to do. I want you to go into your calculator, and we're gonna type in everything on that right side of the equal sign, okay, which was 3 squared plus 10 squared minus 2 times 3 times 10 times the cosine of, what was our angle? 55. Okay, this is what a squared equals. Okay, now I'm not going to write this down. That would be a waste of pencil lead. Right? It's not our answer, and I don't want you to round it and then square root it. We know that a squared equals what we just typed into our calculator. So what do we need to do with our answer? We need to take the square root of second answer, the answer that we just got. My calculator did the work for me. Now I'm going to write down the answer of 8.64. That was confusing? Oh, it's like, what can I help you with? Okay, that was kind of nice. All right, so now we need to find the two angles. Yeah. Okay, Grayson just asked, can we use the law of sines for the rest? Can we? I'm not gonna stop you. Oh. The only thing is we're gonna have to be careful. So the law of cosines may be a little bit more involved. However, you are never going to have to think about whether your answers are right as long as you do the correct algebra. Okay. Remember, we have that issue with the law of sines where we can't get an obtuse angle with inverse sine. So if we're going to switch to law of sines, we do not want to find the biggest angle with law of sines, just in case it's obtuse. So I am not going to find angle C first. It's across from the biggest side. If angle C is obtuse, the law of sines is not going to help me get the right answer. So I'm going to find angle B with the law of sines because I know that I'm not going to have a problem. It's the smallest angle. It's going to be acute. So if we want to switch, we can say, okay, the sine of angle B over 3 equals the sine of 55 degrees over 8.64. Okay. We started out with side angle side. We will only have one triangle. I know that we've switched to the law of sines, but since we started out side angle side, we only have one triangle no matter what. What acute angle are you getting? Awesome. Okay. Oh, and once we have two angles, man, finding the third is so nice. And it is a good thing that we found these angles in the order that we did, because if we would have used the law of sines to find angle C, our calculator would not have given us 108 degrees. Okay. Now, if you're worried about making a mistake with that, then use the law of cosines all the way through. But law of sines is way easier to set up and use, isn't it? Okay, so you have to decide, do I want to have to think a little bit, or do I want to do a little bit more algebra? Okay, but you cannot get into a situation where you start out with law of cosines and you switch to law of sines and find the biggest angle. It's not going to go well for you. Okay. All right, are we okay with these three measurements? Okay. Everyone's looking at the clock like I'm like taking forever. Still 20 minutes. We have plenty of time. Okay. All right, let's look at this guy. Juniors, a month from today is ACT day. Good. No. So Cotillo will them. You are not. You are not. All right, so we have side, 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 which means we have to use the law of cosines. Now, we've decided that switching to law of sines is kind of nice because it's a lot easier than setting up the law of cosines. Okay. If I want to start this problem knowing after the first measurement I can switch to law of sines, what might be the best angle to find the largest? If I'm going to use the law of cosines to find one angle, let's make it be the largest angle. So let's find angle B first. So if we're going to find angle B, then we are going to take 20 squared equals you're right, it's not. So what should we find first? A. Mrs. Holman. Oh. 34 squared equals 18 squared plus 20 squared minus 2 times 18 times 20 times the cosine of angle A. Now, here, please do not work ahead of me. I do not want you to do the incorrect orders of operations, okay? We need to isolate cosine of A so that in our calculator, we can take inverse cosine, all right? So, can I combine all of this right here? No, this stuff is attached to cosine of A. So what we can do is we can take 34 squared and we can subtract over 18 squared and we can subtract over 20 squared. Can you do that for me, please? Take 34 squared, subtract over 18 squared, subtract over 20 squared. So you get 432. Okay. Then, can you tell me what 2 times 18 times 20 is, please? So we have negative 720 as the coefficient for the cosine of A. Okay. Now we can take the coefficient of A and divide it, or the coefficient for cosine of A and divide it over. So the cosine of A is 432 over negative 720. And now at this point, we can take the inverse cosine of this fraction. Make sure you have that negative in there. Why are you doing inverse sine? It is inverse cosine. I know that we're in a habit right now of inverse sine, but make sure you're using inverse cosine. 126.87 degrees. Cool. Okay. Can somebody tell Grayson what I said about multiple solutions? Okay. The only time we are going to get a potential 2-solution triangle is when we start with side-side angle. Okay. If we start with something else and then switch to law of sines, there's still just one solution. Did you hear that this time? Okay. So maybe like focusing on this instead of your homework would be a good idea so you can hear those things. But only for side angle. Okay. Angle side, if you will. All right, so now you can do this again for another angle, set up the law of cosines. Was this your favorite? It's a little bit more work, isn't it? But as long as you do your order of operations correctly, you know you're not going to get a wrong answer, okay? But it is easier to do the law of sines. So if you want to switch to the law of sines, cool. We can take the sine of angle B over 20 and set it equal to the sine of 126.87 over 34.
So is it because this one for angle A is obtuse, it doesn't matter what you
Exactly. That is a good point. Okay. We already have the obtuse angle. We know the other two have to be acute. Okay. Which, Isaac, is why we picked that one first. So then we wouldn't have to worry about it. Which acute angle measure do we get? .07 according to Hank. Do you agree with Hank? That's good. So then what's left over to add to 180? As long as you know the formulas and how to use them, this is really a matter of, can you use your calculator properly? Okay. A lot different strategies than we were talking about in chapter 5, right? Do you see what I mean? How this is a lot more black and white than it was last chapter. A lot more procedural. This is what you need to do. This is what you need to do. Last chapter, there was a lot of like, well, you could do this, or you could do this, or you could do this. Here we have more of a method. Okay. Now I did promise you that I would teach you 2 different area formulas in this chapter. Okay. So on Wednesday, we talked about the area being 1/2 times side times the sine of the angle in between. And you practice that on Wednesday. Okay. Now I want to remind you of this Eurons formula. If we know side, 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 we don't have to solve for any of the angles. You can use this formula right here to solve for the area of your triangle. So go ahead and write it down. Well, right. So the red is the area where you have to first make the S calculation in order to use the red formula. So step 1, find S. Step 2, find area. This year's supposed to get storms tomorrow. Like spring is here, a little early. All right, let's find the area of this triangle right here. All right, so we have a triangle with 3 sides, which means we can use Eurons formula. So step number 1, we need to find that weird S value. So S is 1/2 times the sum of our 3 sides. What do we get? $126. Okay, that was rough. I would literally put it in like this: 1/2 parentheses 43 plus not 89 plus 120 equals. Then you don't have to worry about messing up order of operations. Okay, so then your area is going to be the square root of S times S minus side times S minus side times S minus side. And guys, let's use our calculators to help us. Don't individually find those three differences. Just put it in your calculator like you see it right here. That's a waste of time. Square root of 126 times 126 minus 43 times 126 minus 89 times 126 minus, was it 120? Boom. Just plug it in exactly like you wrote it on your paper. What was that number? 0.7. And we would have to say square meters because we're talking about area. Why centimeters? Okay. Second. What? Okay, so over the weekend, you have homework that will allow you to practice the law of cosines. There will be a couple word problems. Don't just skip them because they're word problems. I need to see that you made an effort. At least draw the picture in your notes or in your notebook, whatever. On Monday, we will review for our quiz with no corrections on Tuesday.